Okay, so first, part one of Unit 3 video notes. Unit 3 is going to continue what we already have learned about ratios and use some of that information with measuring and units. This first little summary is giving us some ideas to help us estimate measurement of units. I marked a couple that I use. I would like you to read through all of them and choose a couple that will help you to estimate units. Because a lot of times kids are like, I don't know how much this is or that is. Two I really like. I like the centimeter, about the width of my pinky, and the thumb going to your knuckle is a good one. Yes, I have an owie on my thumb. So I would like you to read through a couple of those. Choose a couple in each column that you're going to try to remember. Okay, lesson 3. The size of the unit that we measure affects the measurement. If we measure the same quantity with different units, it will take more of the smaller unit and less of the larger unit to express the measurement. Here's a really good example. We have 4 yards, which is this darker color. You can see it's cut into 4 equal sized pieces, which measures exactly 12 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here you can see 3 feet in a yard, 3 feet in a yard, 3 feet in a yard. So if there's 3 feet in a yard, 1 foot is 1/3 of a yard. It takes 3 times as many feet to measure the same length as it does in yards. And it takes 1/3 as many yards to measure the same in feet. So let's see what they're talking about. That means I have 3 feet for every 1 yard. If I wanted to know what 1 foot was, if I wanted this to be 1 foot, we'd do the same thought process with our ratios. How do I turn a 3 into a 1? I divide it by 3. I have to do the same to the top and the bottom. Now, some people call this the giant 1. I think I might start talking about that with my classes. And the reason it's called a giant 1 is because 3 divided by 3 equals 1. So if I take a number, divide it by 1, I have not changed the value of the number. It's still an equivalent fraction. And then this becomes 1 divided by 3, which is 1/3. Or if you do a decimal, it's going to be 0.333. I prefer to keep it in a fraction. So 1 foot is equal to 1/3 of a yard, or 3 feet is equal to 1 yard. You can also do the same idea with a table, feet and yards. 3 feet to 1 yard. 1 foot is 1/3 because 3 divided by 3, or number divided by itself, 1 divided by 3 is 1/3. And it is more accurate to stay as a fraction, because if you divide that, you end up with 333 repeating forever, which is not as an accurate of a measurement. All right, turn the page. Circle the larger unit of each measure and determine if it's distance, volume, or weight. I'll just go ahead and do these with you. 1 meter, kilo means 1,000, so this would be 1,000 meters. Well, 1,000 would definitely be greater, and that is a measure of distance. A yard or a foot, well, a yard is 3 feet, so this is also distance. A cup and a quart is equal to 4 cups. And this is volume. Liquid is usually your volume. Pound or an ounce, there's 16 ounces in a pound, which would be, this could be volume or weight, mass. Liters, this is 1,000th. So a milliliter is 1/1,000th of a liter. So So this would be greater, and that is also going to be a volume because that's your liquid. And then gram or kilogram, that's 1,000 grams. So that is our weight. Please do number 3. This classroom is 11 meters long. A meter is longer than a yard. So if I measure the length of this classroom in yards, I will get 11 yards. Oh, I will get less than 11 yards. Do you agree with Claire? Explain your reasoning. So I'm thinking if this is my meter and this is my yard, right? Meter, yard. If I do 11 meters, which I didn't do a really good size, let's make these smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say that's my 11, right? I'm just going to say these are my 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 meters, 11 yards, which is longer. So if I need to do yards, I'm going to have 11. I'm going to have maybe 12. I'm going to have maybe 13. I would need 13-ish meters to be about 11 yards. So it takes more small pieces to equal the larger piece. All right. Tyler's height is 57 inches. What would his height be in centimeters? So if I look back on the first page, an inch is about our thumb. A centimeter is about a pinky. So let's just do a rough. So there's my 1 inch. And there's my centimeter. So I could even say there's maybe there's even about 3 centimeters in an inch. Or even if there's 2, let's say there's 2. So I'm going to say centimeter to inch. There's 2 centimeters in my about 1 inch. So if inches are 57, what is my approximate answer? My answer is C. It'd be 2 times 57 times 57 is 100. 2 times 7 is 14. 2 times 50 is 100. 114. Which is very close to 144 because it's approximate. All right, part 4, lesson 4. When we measure in 2 different units, the measurements form an equivalent ratio. We can reason with these equivalent ratios to convert measurements from one unit to another. Suppose you cut off 20 inches of hair. Your Canadian friends ask how many centimeters was that? Since 100 inches equal approximately 254 centimeters, we can use equivalent ratios to find out. So here's our example. We started with 100 to 254. they decided to divide by, or I can decide that 100 divided by something is 20. Well, 20, 40, 60, 81. So there, I know that's divided by 5. So here you could divide by 5. You could also find your unit rate going to 1, which means they divided by 100. And then once they got to the 1, their unit rate, you could multiply by 20 on both sides. So their reasoning is the first easy way to solve this problem, find out how many centimeters are in 1 inch. We can then multiply the 2.54 and the 20, which is what happened right here. And you find that 20 inches is approximately 50.8 centimeters. How does finding the rate per 1 help solve conversion problems? When we know this per 1 or the unit rate, it can be multiplied by any number. And that makes it a lot easier for calculations. All right, practice problems. Priya's family exchanged $250 for 4,250 pesos. They have it set up in the table. If Priya bought a sweater for 510 pesos, how many dollars did she spend? So we go through and figure out these parts. How are we going from a 250 to a 25? How could you go from a 25 to a 1? And then how would you get to a 3? So to go from 250 to 25, you should notice that's a change in only that 0, which is dividing by 10. Dividing by 10 is a 0, so I don't even need the calculator on that. That's going to be 425. From 25 to 1 is dividing by 25 because we know dividing by ourselves. So 425 divided by 25 would be 17. Why am I timesing it by 3? We're going to find out. Times 3 times 3. Oh, I know why. 17 times 3 is 51. And then how do they get to 510? Times by 10 again. Times by 10. You should be able to do all of those calculations. We've been doing these calculations. It is just a little time consuming. Now, if you're not sure how to go from 250 to 10, remember it's division. 250 divided by some mystery number equals 25, or 250 divided by 25 equals mystery number. All right, Lynn knows there are 4 quarts in a gallon. I'm just going to start my table because I know I'm talking about 2 different units. And there's my ratio, 4 to 1. She wants to know 6 gallons, but she cannot decide if she multiplies 6 by 4 or divides 6 by 4. How should she do this? For me, I like a table. So they want a 6. How do I turn 4 to 6? I don't know. So think about this, how I could go this way. I could go, let's make it into a 2. 4 to a 2 is half. So 1 to a 2. If this is half, which is the same as divide by 2. And then how do I turn a 2 into a 6? That's times 3. This is times 3, so that's 3 halves, which would be the same as 6 divided by 4. So let's do this again. Quarts, gallons, 4 to 1. Turn it into a 6. Well, how do I turn a 4 to a 1? Divided by 4. So if this was divided by 4, 6 divided by 4, which simplifies to the 3/2. So I have 4 quarts. I want to know 6 quarts. I divide quarts by quarts to figure out the gallons. But the table always makes the most sense for me. All right, we have one more lesson on this first video. Hopefully we can see through this. This might be kind of hard for you to see through. Diego ran 3 kilometers in 20 minutes. Andre ran 2,550 in 17 minutes. Who ran faster? Since none of the times are the same, we have 2 strategies. We can find the time it took each person to travel the same distance. The person who traveled that distance in less time is faster. Or we can find the same distance, find the distance each person traveled in the same time. The person who traveled farther distance in the same amount of time is faster. It is often helpful to compare distances traveled in 1 unit of time. For 1 minute example, which means we're going to find the unit rate. Which they sometimes just call the rate. So here's Andre and Diego. Here's our original 3 for 20, 250 for 17. All right, so 3 kilometers in 20 minutes is how this started. And they're making you assume, well, how do I turn that to meters? There's 1,000 meters in 1 kilometer. And if I need 3 kilometers, that means I times by 3, and that ends up with 3,000 meters, which is how we got this number right here, which they then cut in half. Half of 20 is 10. Half of 3,000 is 1,500. And then we divide it by 10 and divide it by 10. You can see from here, this one they divided by 17, divided by 17. They both ran 150 meters per 1 minute, so they ran at the same speed. I'm going to change color. Finding ratios tells us much about a quantity. Quantity A per 1 unit of quantity B is an efficient way to compare rates in different situations. Here are some other examples. Miles per hour, dollars per pound at the store. We've talked about some in class. One that happens a lot is dollars per gallon. When your parents are going to the gas station. Money per gallon. Money per hour if you are working for someone, getting paid. And when we have a lot of these running ideas, we're talking about meters per second, right? Any other ones that you can think of? Mai and Priya were on scooters. Mai traveled 15 meters in 6 seconds. So here's my table, meters per second. That's for Mai. And here's my table for Priya. Meters per second. Who was faster? I'm going to set it up for you, but I want you to finish it. All right. How do I turn a 15 into a 1? There's several things I could do. I could cut 6 divided by 3 is 2. 15 divided by 3 is 5. And then still cut it in half. Or I can just go straight to division. Divide by 6. divide by 6. 15 divided by 6, 2.5 meters. And Priya, well, 10 to a 1 is divide by 10. Divide by 10. You can check it with your calculator, but I really want you to start to notice dividing by 10 is always a place value. That place is gone, or we could say there's an invisible decimal there. So this becomes 2.2. So who is faster? Well, Mai goes 2.5 meters in 1 second. Priya goes 2.2 meters in 1 second. So Mai is faster. Here are the prices for cans of juice of the same brand. I would probably still do tables, cans, money, cans, money, cans, money. 4 cans for $2.48. Find the price of 1 can. 5 cans for $3. Find the price of 1 can. And 1 can is 59 cents. Now you can do it any other way you'd like. That's just my strategy. So I'm going to divide by 4. 248 divided by 4 is 62 cents, I believe. 2.48 divided by 4. Oop, did it wrong again. 2.48 divided by, oh my gosh. 62 cents. $5, $3 divided by 5 is 0.60 cents. So store Z has the best price per can, 1 penny less than store Y, a couple cents, 3 cents less than store Z. All right, we're going to stop right there for your part 1 video.